In today's session, we will talk about subnetting Class B IP addresses. As we have seen in the previous session about IP addressing and subnetting, we have taken example of Class C address. But now in Class C address, we have only first octet, only one octet for host representation. So we see only the maximum 254 hosts are there. But if we need more hosts than 254 hosts, so we can go to the Class B address. In Class B, the total number of hosts is basically 65,535, and as you know, the subnet mask for Class B address is 255.255.0.0. The 2 octet in place of 255 means this is a 16 bit for network address, and 2 places 2 octet for 0 means 16 zeros for host. So if we convert this subnet mask to binary address, so it looks like this: 16 ones and 16 zeros. So 0 represent host portion in this address. So we can also write it as /16 in a slash notation. We take an example of 1000 host requirement here. So for this 1000 hosts, you know, because the Class C address, we can have maximum 254 hosts. So it is not possible to get 1000 hosts in the Class B, a Class A C address. So we will take an example of Class B now. In Class B address, if you see, we have 16 bit for host. Now for 1000 hosts, how many bits you need? This is the first thing you have to work out. If you find the exact number of bits needed for this 1000 host representation, so it will be easy to subnet now. The process starts the number of hosts equal to 2 is power h minus 2. So it should be equal to or greater than 1000, because this is my requirement. So if we write this h value is 10, so it will become 1024 minus 2. Two numbers are used always for all zeros. First number is for network address, and all ones last number is a broadcast address. That's why these two numbers are always less in any network range, in any host range for a host representation. So we will be having 1022 hosts in this network using 10 bits for host representation. So this will meet our requirement. We need 1000. So we need 10 bits to subnet. Now next thing comes is, if we use 10 bit for host representation, so what is going to be the next subnet mask? So if we make this, we take 10 bits out of them. For example, this 8 plus 2 more, so we have taken 10 bit for host. The remaining bits are 6. So we have taken 10 bits. So in the so this 16 and plus 6 will be added more in the network portion. So it will become 252 in the third octet instead of 0. So it will be slash represented as /22, because 2 bits has been added to the host portion. If you say this 16 bit host portion, we have taken only 10 bits out of the 16, and still 6 is in the subnet. So how many subnets will be available in this /22 network? So if you see here, after taking 10 bits for host, remaining bit is 6. The number of hosts equal to 2 is power 6. The number of bits used for the network is 6 here. So it is going to be the 64 subnets. Okay, now one thing is here, up to this mark it is same as Class C address, but what we need to do work here extra is, we need to find the block, how much block is needed to represent this 1000 hosts. As you see, if one octet can have maximum 54 hosts, so if it is below 54, there is no problem. If it is more than 54, obviously it will not fit to the one block. So we have to find out how many blocks we need to represent this 1000 hosts. So to find the number of block needed, you have to put the 2 raised power h, that is a bits we are using for the host, and then divide by 256, because one block is going to have a 256 numbers. So if you say 1024 divide by 256, it is 4 blocks. So we need 4 blocks to represent this network, and for 1000 hosts. So here, because each block is going to have a 256 addresses. Now up to this mark it is clear how many bits we need for host representation and how many bits is remaining for the network. So using the host bit, how many hosts we are going to have in the same network, and what is the new subnet mask, and how many number of subnets we are going to have after this subnetting. So the next thing is how to write the address. This is bit different than the class C address, because there we have only one block, here we have more blocks. So if my network start with 172.16.0.0, using the 4 blocks, so I will start with 0.0 and I will go 3.0 last. If I say 3.0 network range I will use, so starting with 0.0 and going 3.255 is the last address which we are going to use here in the range. So 1.16.0.0 in the first network block, then 0.255, then second block 1.0 to 1.255, third block 2.0 2.255, fourth block 3.0 3.255. So start with the network start with the 172.16.0.0 to 172.16.3.255. So if you see here, one network is using 4 blocks, 0 to 3. Similarly, second network will be 4 to 7, and third will be 8 to 11, and so on. Last network will be 52, 53, 54 and 55. So 52.0 to 55.55. So this way we can have 64 hosts in this network. So this is class B subnetting for FLSM, fixed length subnet mask. So we'll see VLSM class B subnetting in next session. Thanks for watching. If you like this video and you find this video informative, kindly like and subscribe. Okay, thanks for watching.